Out
No.
further adducts.
I don't know what any of this shit is, and I'm fucking scared.
First, you're gonna tell me about this science stuff.
Sorry about that. What is a scientist?
You caught me like I'm experimenting with
Science!
It's like magic with electricity.
I know that. I'm not stupid. I'm smarter than you.
The smartest scientists in the entire world all agree.
Science is a liar sometimes.
Seriously, this could not seem less scientific.
Those idiots don't know anything about science.
It's science.
I believe it's pronounced science.
This is the least scientific thing I've ever seen. So I'm just experimenting with them?
You be quiet!
Thank you, scientist.
It gives me a nice 40 seconds or so to do whatever the hell else I can think of. That probably isn't necessary. But yeah.
Cool.
Howdy, folks. Welcome to Under the Guise of Science.
Hi, everybody. I am Chris.
And I am Charles, and I'm going to do the whole episode like this.
I gotta go. I don't even think I could do that for however long we do it.
I'm sure I could. I believe in me. there's certain stuff I'm committed to.
Like, if you stay in it for 45 minutes or so, it probably gets funny again, but I don't want to test it.
Yo, minute 51 will be ridiculous. Regardless of what we're saying.
Everything will be gold. It'll be better than the Rodney voice.
That would be something.
Yeah.
That would be something.
Good evening, or whatever it is for you.
Yeah,
out there. Yeah.
Whoever. I hope it's good morning. I hope it's a Tuesday morning commute from your toilet back to your bed, because I want you to be able to sleep in on Tuesdays.
Oh, that's very nice of you.
Thank you. I get to do it every now and again, so it's pretty great. I'm not gonna lie. Sure, I could. Having weekends off like a regular person is probably also pretty great too. But
not if you have kids. There's no such thing.
Fair enough.
Yeah.
You haven't had a day off in forever.
No, I haven't. But such is the choices we make.
This is the life we chose.
That's right. We also chose to do this podcast.
We did.
Back at it again.
Very excited about this one. One, because we haven't recorded in a bit, and number two, this video is the shit.
Yeah, it was a very cool video. We will link this in the description.
They fucking I get it why they were like, hey, hit us up with some money, please, at the end, because I mean the amount of hours that had to go into making that fucking thing.
Yeah. Oh, yeah. Whoever does that, they know their way around video graphics. I think the name of the channel was Cosmo with a K. Kosmo. Yeah.
I believe you are correct.
Okay. So credit to them. And we will link that link below.
Now you get 200 points for that. The board is still yours.
Thanks. So, yeah, it was about... Well, it wasn't even about necessarily exoplanets. I think the episode, we're going to be focusing on exoplanets, but the video itself was more about just stuff that's relatively close by cosmically speaking, I guess.
Yeah, I never remember 100% what the right words is to use for that, because it's like universally speaking sounds like just like you're making a broad statement.
I think it might be cosmologically.
Yeah.
But it might not.
All right.
It sounds right, or astrologically, or whatever.
Until someone tells me otherwise. And even in that case, I'll still say, well, Sharon said it was this. So you're stupid.
That's true. If I say it, it is fact on this show. That goes for you, too. You've told some straight up lies that I was like, oh, interesting. And then you're like, no, I made that up. Oh, okay.
I want to do, and again, this requires time, but I'd like to take a compilation of me telling you a lie that gets by you, and they go, no, I'm lying, because there's at least 3 or 4 that I did that to you.
Yes, absolutely.
I have another one for you. I want to chop up all of your. Actually, no, it'll be mostly you. It'll be starting with me because you were the first to do it, and I don't think you've ever done it again. Is get up and go pee.
Okay.
And then I just want to chop together you talking while I'm peeing, like a little montage.
Okay. Where I have to scramble for, even though I don't know why I do it, I feel like it's dead air and oh no, people are listening, but I could just sit here and do nothing and you could just chop it out and be like nothing happened.
Yeah, like I could even just hit pause and then we could both stop doing what we're doing.
Yeah.
And then I could just hit play again. And
showing my age. I feel like it's dead air. Dead air isn't even a term anymore.
Yeah, right?
I know people like I've seen podcasters talk about the hours that they spend on editing, going through and cutting out all the and just like in between words and just try to knit it together nicely. When we're not that kind of podcast, first of all.
No.
And second of all, I feel like it takes a little of the soul out of it. Like, I don't know.
Yeah, like there's times that like you could tell on a really well produced one, but even there's other, like any of the ones that are live all the time, like or that broadcast live originally, like just like Rogan, for off the top of my head, that's just nonstop because there's no. I mean, you could probably edit video if you wanted to, I guess, but
yeah,
for the most part, yeah. You know what? Now that I think of it, that very well could be edited a bunch too. Because I'm like, you can't edit video and sound. Who's ever done that?
That's madness. No, but I know what you're saying. That definitely is the kind of podcast that sounds more like just a conversation, letting it flow, and
yeah.
I doubt they're doing that
ever.
Yeah.
Well, yeah. Then there's other commercials. Well, other ones where they're like, "All right, we're gonna take a quick break. We'll be right back." And there's no live read in there or anything. It's just pause and we're back. So it's only like a half second apart.
That's interesting.
It's kind of funny.
Yeah. There's no reason for a break there, or at least no reason to tell everyone that there's a break there.
So yeah, if you guys are just finding out about podcasts with us, go check out some more of them because they're pretty cool.
They are a thing, turns out. Yeah.
Oh my god! You imagine when somebody's first like, I want to rephrase this, and the one that's not like parents aged family. Sure, I could absolutely see this being their first podcast. It's doable, but like anyone that's under the age of like 30, come on.
I know. Do they even listen to podcasts anymore? Or has that jumped the shark? We're on too late, and the kids are like, "Fuck that! I want 45-second TikToks."
Yeah, just 45 seconds, just real quick, real short attention span. Done. Yeah. Ain't nobody got time for that.
This generation
and their podcasts or not podcasts. Don't mind me. There's the one thing I forgot to plug in the laptop.
Ah, power's dying. We need that.
Yeah, it's not at critical levels yet. It should just be, another second or two. So I'm not leaving it up to you to kill dead air this time. I'm gonna help.
This time it sounds like you're doing work outside the ship or something.
I've just breached the main hull.
Do you want me to hit anything?
There's a red light that's gonna flash in a minute. It means we're out of gas. Or something. I don't know. That's outer space repairman. Ba-ba-da-ba-ba.
Like it. Repairman can tell whether or not there is gas.
Now, if you were to get to one of these so-called exoplanets, you'd need quite a ship.
That you would. I mean, as it is now, it takes light a couple years from even the close ones. Like when we're talking about our neighborhood, a lot of these are within, I'm going to say 50 light years or so, some closer, but that's kind of like the extent of our local bubble.
And the I will, one of the great things I loved about how they made the video is just they didn't go out of control with graphics. Like it was predominantly just like animations of what shit's gonna look like, or what they assume shit would look like.
Right.
Rather, and they'd only throw in every now and again. By the way, this is how hot this would be compared to your planet. This is how big this is to your planet. This is how big this is compared to your sun. Just like real quick graphic, and it's like because that's immediately it's like all right, I need scale for this,
Right.
to
Yeah,
kind
how
of help
can
me
you relate
understand it. Yeah. And that made it. That I feel like it answered my first three questions every time I was watching. I was like, well, how big is? Oh, okay. Well, what if it was? All right. Well, it can't be too hot. Oh, okay. It's not too hot. Okay, great.
Checking off all the boxes, and they also do the rotation and orbit.
Oh, that's right. Yeah.
In terms of Earth times and Earth orbit and stuff, and even the distance. I mean the distances in AU. That's like the standard. That's the ruler, 1 astronomical unit, and that's the distance between the Earth and the Sun. So when they talk about other planets, that it's 0.73 AU, it's still the same thing, comparing it to the thing that you're used to in a way.
I am so glad you pointed that out because I knew we talked about it and I couldn't remember what it was immediately. And then at just one point during the first time I watched it, I was just like, I'll just assume it's like 1 light year. But that's so much like that's because in my head I was like, oh man, so how much of 1 light year how long does it take light to get to the Earth? I mean, that's got to be point whatever of an astronomical unit.
Yeah.
Nope, that is the astronomical unit.
Right. That's the ruler. That's all we got.
Okay. Oh man. So, all right. Some shit's way closer than I thought it was.
Yes.
Well, this is already a very nice surprise.
Nice. glad I could help.
It's like doing a whole fucking. It's like thinking that the Earth is. Oof, no, I already cannot make this metaphor.
It puts a different paint job on things.
Yeah, there you go.
Jerky Boy reference. Belly out.
Oh man, it's like if you thought something was a lot bigger, but now it's a lot smaller. Thanks, idiot co-host Charles. Oh my god.
Well, we can move on to the first thing with Barnard Star. Who is Barnard? I didn't look that up, but he has a star, or she has a star. Or
Barnard Star sounds like a guy who played in the ABA.
wow, yeah, it does. Yeah,
Barnard Star is a point guard, definitely.
yeah, he led the league in assists.
Yeah.
Yeah, came in second in the 3-point competition.
And for some reason, after the merger, his game just never translated. It just must have been the decreasing in the size of the necessary talent pool.
Barnard Star is small. It's a red dwarf, so maybe it's related to actual size. NBA was too big for
I believe his coach's name was actually Red Dwarf.
him.
Neither of which was a nickname, oddly enough.
You're right. Yeah, Red Dwarf was his given name. Yeah, people just named their kids Red in the '60s. Have to grow up with that.
And what I guess this for a little bit more reference. The sizes of the stars, without gloss over, because we definitely talked about that once already at some point.
Yeah,
But
I mean,
yeah,
Red Dwarf is smaller than the sun, than our sun. They're typically smaller and cooler than like your main sequence stars, which the sun is. The size ranges. I mean, I don't have a direct number, but half the size of the sun to 3/4 the size of the sun. Some maybe even smaller than that, but it has to be big enough for fusion to start in the first place, but it's still not as energetic, not as powerful as a main sequence star. So in cases like that, for red dwarfs, the Goldilocks zone is a lot closer to the star itself than it is for a star like ours. So some of them, when they're a little bit closer, they're actually in the Goldilocks zone.
Goldilocks zone question. Is there a standard like kind of ratio of class of planet, not planet, class of star, or the average distance Goldilocks zone versus of a what's the really big ones?
Like the super giants.
Super giants.
Red giants, red super giants. Yeah.
Okay.
Yep. Absolutely. And it's like you said, it's an average. So the stars themselves vary in intensity and vary in the energy they give out. So it's an average of these types of stars average this amount. So there's a range where it could be from here to here that liquid water can exist. That's the the key to the Goldilocks zone. So yeah, it's kind of a range depending on how big the star is. Like when our sun, I think we've talked about this before, but when our sun reaches the end of the main sequence phase and goes into the red giant phase, the Goldilocks zone will move out to Jupiter-ish for, instead of being where it is now.
Gotcha.
Yeah.
All right. So so red dwarf, red giant, or the blue, white, yellow. What's some of them other colors?
There's a bunch of there's some white dwarfs. There's the main sequence stars. There's like when we talk about the blue, they're still main sequence stars, but they're just huge, and they burn hotter and brighter and more intense, and they give off a blue hue because, again, on the light spectrum, as you get towards the blue side, that's more energy. When you get towards the red side, that's less energy. So that's why they appear to be blue. Like we'll talk about Sirius A. It's just a star, but it's huge, and that's why it's so bright, and it's super hot, and it dominates. There's another white dwarf in the Sirius binary system. It looks like one star to us because Sirius A is so big and so bright that it overpowers the white dwarf Sirius B that's with it, and you can't see it with the naked eye.
Cool shit.
So they vary.
All right. And then lastly, the sequence. So is it like 3 sequences, 4 sequences? Like, so there's main sequence. Is there like a starting sequence, ending sequence kind of thing?
I think that's just the type of star. I think before that, it's kind of like a protostar or, the nebula, and becomes a protostar. And then it could either be, depending on how much matter is in one place. There's actually something called a brown dwarf, which is bigger than a planet like Jupiter, but not as massive as a red dwarf. So a lot of stuff is there. It's hot, it's energetic, but it never gets big and hot enough for fusion to start. So that's kind of on the large planet, small star. It's kind of like in the middle of that. A little bit bigger than that, a little bit more massive. That's where you would get a red dwarf. Some stars, red dwarfs, they can live a very long time. They're not a lot of energy comes out of them, but that's their life. And then when they burn out, it's just going to be some kind of core, some kind of husk that's left. It might, I don't know if it goes down to being a white dwarf or if there's just something else that's left the core of that. But they can last trillions of years versus then a star like ours, which they call a main sequence star. That's kind of in the middle. Bigger ones, like there's giants, like I think Rigel is one of them. It's just like this beast. They have different names for them. There's another type of star that's just monstrous. That's like I think it's called the Wolf-Stevenson star. So they have all different names of all different types of stars. So yeah, it starts to get, so it's not that main sequence is, first sequence, second sequence, third sequence. It's just another label for a star.
The Wolf Stevens star on the Hollywood Walk of Fame. Wolf Stevens, famous 1970s soap opera actor. You remember him. Apparently, I think every star in the universe is some dude who is famous in the 70s so far.
That seemed like it was a popular last name, though, for a time. There are a lot more stars than there are now. Now it seems like Star is kind of a first name. Made the transition.
Yeah.
Star Jones and shit. I don't know if she's still relevant, but that's what comes up.
I mean, I heard of her, so.
It's a name. It's a real person, at least.
Alrighty. I think that's all the preliminary questions I had.
Okay.
Yeah, I guess let's get into these outside planets.
Yeah, so back to Barnard Star, which is about
about 12 minutes ago, right?
But I know all those were on topic. It's not like we got distracted by way worse. That was at least science distractions. I think that's fair. But there seems to be, so first of all, the way that they find a lot of these stars is something called the transit method. I think there's other methods too, but I didn't read up on them, so I'm not going to speak on them. But the transit method seems to be the most common. They're actually launching did launch the Kepler Space Telescope, which uses this, and it's found quite a few exoplanets through this. But basically, stares at a star. The star has a certain luminosity. There's a certain amount of light that comes from it. Every so often, there's a dip. If the dip seems to be regular, like it's some kind of body orbiting in front of the star that's causing the dip, blocking out some of the light, then they start to do the tricks that they do of looking at the spectrum and breaking it into the different components and seeing what types of elements and all that good stuff and various other high science stuff that's a little bit over my head. But they can determine from there if there's an exoplanet or not.
And that's
suspected.
Using spectral analysis?
Yes.
Do that?
That's the definition of what I mumbled through. Well, that's the term for what I mumbled through.
Oh, sweet.
Spectral analysis. Yeah,
right.
that's what pulling the light from the stars and breaking into the spectrum. Yes.
Gotcha. All right. So then I will not follow that up with, what does that mean?
Okay. Yeah, we did it Jeopardy style.
Yeah. It's like it's stoner Jeopardy. You just give the answer and then just, what is spectral analysis?
Nailed it. But that guy, the star that they discovered or the exoplanet that seems to be orbiting Barnard's star, looks to be a cold super Earth. Super Earth being rocky-like planet, usually masses higher than Earth, but lower than Neptune. So some of these can be, 3 times the size of Earth to 5 times the size of Earth, like in that range, but usually pretty rocky.
And they did use that term a few times. That was also one of my questions. Man, you were just knocking out all my questions. If this was the stuff that you're going to tell me, Moon Contest, you would have been just knocking out all my questions.
Damn it. We should have made this a moon contest.
I don't know anything about this yet still, so no. So yeah, spectral analysis. What was the?
So, but unless there's some kind of planetary energy, whether it's tidal or through nuclear decay, it's unlikely that there would be enough energy from this star on that planet for life to form.
Excuse me.
Sorry. Oh, and that exoplanet. I keep saying star. Bear with me. A couple drinks in, as per usual. So I'm going to say stupid shit, but
I will bear anything you ask.
That's the goal of the show. I'm going to say smart shit and stupid shit all at the same time.
It's easier. Can't remember all the smart shit.
Right.
It's just kind of
palate cleanse.
Barnard. Oh no, I think I had a lunar disc real quick. Is that a thing that they said? Did I mishear that? Oh yeah, they said that about I think it's Barnard Star B, right? That's the closest one.
Yeah, I mean, the star, they usually just give it the name, and then anything else will have B, C, D.
Oh, that's how they could tell. The Barnard Star got. That's how they discovered it or something, because it moves like 100 and through the lunar disk in 182 years or something like that.
Basically, it's crazy fast. It moves crazy fast across the sky in comparison to other stars. I guess the lunar disk being from our view, it must be like where the moon goes. I'm not really sure what they mean by lunar disk, but I guess when they say moves through the lunar disk, it must be in relation to the path the moon takes, I'm guessing. I just know that it moves fast.
It sounds like it could be Clutch lyrics. As it moves through the lunar disk. Old Clutch, anyway.
Yeah. Still talking, not trying to be bluesy.
Yeah.
Which I dig, don't get me wrong. I'm just saying.
Yeah. I can like two things.
Right, yeah. I can like old Clutch and new Clutch. It's just different. But yeah, currently Barnard Star is 6 light years away, but it's whipping through, and it will eventually be the closest star to us, which is currently Proxima Centauri, but it's on trajectory to move even closer than that, which is, again, 3.8 light years away or something. So not close by our standards, but
it's still not too bad.
Yeah. Not shabby.
Still won't be visible with the naked eye, though, would it?
No, it's too dim in general. We can't see it with the naked eye currently. Too dim. Well, I think that's the case with a lot of red dwarfs. Like even the next one, Wolf 1061, further away. But again, it's a red dwarf, so I don't think we can see that with the naked eye either.
And what's Wolf 1061's deal?
Wolf. This one has, it looks like maybe 3 rocky planets. So Wolf 1061b seems like the most Earth-like as far as size, composition, all that good stuff. Only problem there is it's way closer than this planet, and it is tidally locked. Tidally locked, similar to how the moon is to us. Those planets, when you really can't have life on those planets, with one side always facing the star, one side being always in the dark. the temperature differences will be drastic, especially that close. It would probably be close enough to cook metal. The only place you could theoretically live is on the border, where it kind of be eternal twilight. But the storms would be insane just from the two temperatures on the different side merging at those points.
Oh wow,
Yeah,
that's fucking crazy. Is there
not a,
is there atmosphere?
it looks
Either
like
that
there is
close?
atmosphere. Yeah. Well, actually, sometimes when they are that close, that would get stripped away, and they wouldn't have an atmosphere. And then in that case, there would be. This may be one of those planets. Now that you mention it, that it just roasts away, and there's nothing left. Kind of similar to Mercury in our own solar system. It doesn't, even though it's smaller, it has no atmosphere, just from getting beat by the sun.
Scorched. SPF. I don't know.
They don't have it. SPF non-existent.
10 to the 490 12th.
Right. There is a planet around Wolf, so this is C, because as you go out, they just throw another letter on it. The next one, so Wolf 1061C, is in the Goldilocks zone. This one is a super Earth, though. And it looks like, again, spectral analysis and all that kind of stuff, unless there's some kind of dense atmosphere, it's probably similar in temperature to Mars.
Ooh.
Yes, close, but no cigar.
Still too cold.
Yep. Unless there's enough greenhouse gases in the atmosphere to actually trap that heat. And then D is looks like it's outside the Goldilocks zone. It could be like a super Earth or a mini Neptune in this case. It's tough to say which. It's kind of on the border. And that would be too cold.
The super Earth mini Neptune border.
Yeah. Those are two categories of planet sizes.
It would be two way cooler country names.
There's definitely been a point in time where two scientists got in an argument over whether that is a super Earth or a mini Neptune, which I think would be pretty cool to witness.
It would be so great to hear like a very it can't be a super Earth, because and then 3.5 5-minute long barely breathtaking response, and if for nothing else, it's because you're a fucking idiot. That's why.
Right.
You just
That's the response. Your retort.
Yeah.
Because everything you said since I met you has been fucking stupid, so it can't be that. That's what I base my analysis, my hypothesis on.
Fucking RC cola drinking motherfucker. Judgment's real suspect with drinking RC cola when there's Coke and Pepsi out there. Scandal.
Yeah. It's not right. Moving on, I know we kind of talked about Sirius, but hopped over it. But I did want to say it doesn't look like there's any planets detected there. But again, that doesn't mean there's nothing there. That just means we haven't noticed them. Like in a case like Sirius, where it's so bright and there's that other white dwarf there. If there's anything orbiting either one of those, maybe the luminosity doesn't take enough of a hit. Maybe it's not head on the way we're looking. Like there could be shit that we're not seeing. So it's not a definite that just because we don't see it, it's not there.
Is Sirius the one that has red dwarves as well? Each one has a red dwarf, or that's the one later on? That's
that comes later. I think that's
okay.
Castor.
Yes. All right. So then, with this, like, could there just be stuff that could be visible, but just the stars are like overlapping too much at any point? Where there's just too much light.
Yep. It's just anything coming out we wouldn't necessarily be able to see it because of the brightness.
Right, because it would
there's
be
other instruments.
For the most part, like even just casting a shadow, possibly from where there should be a shadow, but you can't have a shadow where there's also just a shitload more light.
Yeah, like shining a light in front of your own shadow kind of negates the shadow in a way. Yeah. Or trying to find a flashlight, someone holding a flashlight standing in front of a floodlight.
Okay.
If you think of it that way, yeah.
That makes way more sense. This was another one, I think, and that they were talking about it moving through the sky. Like it eventually is going to start moving away from where it is. Right? This was the one that they were like, and then in 640 million years, once it's far away, then it'll go into a supernova and then will disappear out of the sky for months. And I spoke about FOMO on a previous episode. Like, it's just like, oh, it's 640 million years. I can't, with all the knowing stuff that I've picked up from talking to you, I couldn't even begin to tell you what the fuck there was 640 million years ago. Like,
not much.
Yeah, there wasn't much going on. So it's just like, this, you would never even fucking, it's not even a chance.
Right.
Not even a chance for that.
Yeah, the last, I don't know, if a star like that, if that happened 640 million years ago and just like lit up the sky and it was just this beautiful, I don't know, like the auroras times 20 or, whatever you're looking at, just this crazy supernova gas, and it's for fucking bacteria and single-celled shit and plankton, and that's who...
They can't even appreciate that.
Yeah, they don't appreciate anything.
Yeah, it's, that was way before its time. Its contemporaries couldn't appreciate the work that whatever star that was doing.
It's true. It always comes the later generations.
They always pick it up.
Multicellular life. Yeah.
I have one more question about this one, I think. So they gave it they were talking about how bright it was to us. How visible would our sun be from far away?
That's a good question. I don't think our sun is nowhere near the energy of, say, a Sirius.
Right.
So that's the brightest star in the sky for us. I would imagine it, depending on how far you are and depending on what was in your sky, if it was another single star that didn't have some other kind of bright thing nearby obscuring it, I would imagine our star would kind of be like, on a clear night, you can see thousands of stars. Like, then you could see our star. But if it's kind of like a overcast night and you can see a dozen, I don't think ours would be in the dozen.
Wow.
Yeah.
Now, and does two-parter, I guess, does our the sun have a name that's not the sun?
I think Latin it's Sol. S-O-L. That's why things are solar. And, yeah. Or Saul.
Saul.
Yeah. Our son's name is Saul.
Yeah. He's a very bright boy, our Saul.
Yeah. The bad birds. They rip my horse's teeth in his face right out.
And they go, Kia, Kia. And they hootin', like hoot down.
Our son's government name is Saul Rosenberg, just for the record. Are you using my panels? Do you care about your carbon footprint at all?
Last serious question. They brought up. Oh, how did they figure it out? Was 2 again? Was that parallax? That was that parallax thing where camera 1, camera 2 kind of thing.
Yeah, I think it was a little bit of that. Probably some of this transit stuff, looking close at it. But yeah, just over time noticing the changes going on up there. Because I think both of those stars, they both orbit the center of mass between them. So it's almost like an infinity symbol the way they orbit, if I'm not mistaken.
Oh, okay.
So yeah, that would make sense if there was some kind of comparison between the two at different points where they noticed that these two were in conjunction.
Neat. Oh.
Yeah.
No.
Yeah, I don't know. I'll be honest. I don't know 100% how they discovered it, that it was two, if it was parallax or not. I don't know if they mentioned that in that video, and I didn't pick it up previously, but that'd be my guess, that it was something related to that.
Yeah, I think in one of the Cosmos ones, like they kind of talked about noticing it, but I don't remember which specific binary star it was.
Gotcha. Moving on, they talk about the local interstellar cloud. Just basically that there's clouds everywhere. In this case, it is a bunch of hot hydrogen, but it's very spread out. And most of there's a solar wind, and then there's our atmosphere, and that kind of keeps away most of it. So we don't really have to worry too much about it. But I think they were saying that just to point out that there's different clouds of gas in various places, and they are huge, and they have their own magnetic sphere. What's the word I'm looking for? Magnetic sphere, I guess. I don't know if it's a sphere. Field. Yeah, that works better.
Nice.
Yeah. So.
And this was another thing that blew my mind. Like both times I watched it, I was like, man, there's just wild packs of gases just roaming the universe. Just fucking shit up because they're super hot, right?
Yeah.
It's like space lava, just probably gobbling up whatever fucking runs over it.
It's very diffuse, though. Like they were saying, it's some one atom per multiple cubic meters, kind of.
Holy shit!
Like, yeah. It's very, very spread out. So to call it gas is kind of like, but it's still gravitationally bound, and it's still one thing. It actually has its own movement trajectory. We're moving through it, and it's moving a different way. And there's another cloud next to it that we're going to be moving into in a couple tens of thousands of years or so.
So even though that they're really big, they're not, for their size, they're not terribly massive. Then, if like the atoms are that far spread out, right?
Correct. Yeah, it's not that dense.
Wow.
I mean, it's still sheer size. It might still be massive just because there's so much of it. But yeah, density wise, it's pretty loose, right? Which we established is the antonym of dense.
That's right.
We'll have to look that up one day.
We'd better not.
Yeah.
Do they measure shit in cubic light years?
No, I don't think so. I think light is just more a distance from point A to point B. Cubic refers to more of a volume.
Yeah, I guess so. Like, how would you, like, because they say how long across the span is in light years of that. So how would they figure out the depth? Like, because
it would have to be cubic. I guess kilometers is as big as it goes, unless they have some other kind of measurement that's bigger.
Make a new one, god damn it!
Yeah, maybe they have one. Gigakilometers or something.
Gigamometers.
That's 1 billion kilometers.
That is crazy. Just giant clouds of shit. Like, I figured it was dust. Like just a dust cloud, and it's like, nope, it's gases that are really far apart. You could comfortably stroll between atoms if you were in that part of the universe.
I guess you could.
Yeah. A comfortable stroll between atoms.
All right. Next up, A.B. Colombe. This one's pretty cool because it looks weird compared to the other red dwarfs that we spoke of. it seems like that it was born in a different cluster and got kicked out by a supernova.
And
And
is this the one that's an open cluster? I believe it.
no,
I believe
I
it
don't know
was
what you
because I
mean.
have it under it. It said
I don't know what that
they think
means.
it was part of an open cluster. That
Oh,
star,
so like they
yeah,
like an open relationship. They
right,
shared. They were all sucking each other off. The
yeah.
stars.
Every one of those stars has "it's complicated" on their Facebook page status.
The open cluster of stars. I
uh,
don't recall, to be honest
yeah,
with you. Is that so? There was. What is it? What does that
I
refer
don't.
to?
I wrote what's an open cluster and put an exclamation point. But we got a
Oh,
joke in
okay,
about sucking off stars again, so it did its
that'll
purpose.
do. Yeah, we'll look that one up if we care.
Actually, if you care, you look it the fuck up, folks.
Right? Yeah, we're doing our job.
You're looking at your phone right now, regardless of what you're listening to or not.
Yeah, they're probably well. That's half the problem. You're
Yeah.
reading something and blocking us out, but we'll take the listen. Like and subscribe also.
Smash, smash, smash. AP Columbe.
AP Columbe. So it's bigger than most red dwarf, higher energy than most red dwarf stars. So scientists wanted to understand why this one seemed different than other red dwarf stars, and it looks like it has more lithium than most red dwarf stars. Lithium typically burns off a lot more quickly than say hydrogen. So it appears that this is a young star. So young being 14 million years old,
Aw.
which when compared to our 4 billion year old star, I mean, 14 million years ago, that was dinosaurs have been dead for 50 million years,
Yeah.
right? And then the star came into the picture.
The proto humans hadn't even come down from the trees yet by that
No,
point.
not yet. Yeah.
Down into the
Still
grassy
earlier than that.
plains. My goodness.
Yeah, but still, that's a young astronomically, I guess. But no, doesn't appear to have any exoplanets here either, and also seems to be quite unstable. It's still finding its groove, still learning how to fuse.
And now the excess of lithium. What was the deal with that? I don't know that you said.
It's just sometimes around.
Or like
I mean,
what
it
why is
exists.
that indicative of the star being younger, the excess?
It usually burns off very quickly compared to other elements.
Oh, okay. So it'll go through that stuff before it gets to other stuff.
Yeah.
There you go.
So most red dwarfs are already plumb out of lithium, and lithium being I think it's number 3 on the periodic table. So it's 3 times the size of hydrogen
And
atomically.
is that the same lithium that is used as a brain-ecological drug?
I
Pharmacological, there
believe
we
it
go.
is.
Yeah.
Yeah, I think it is. It's an element. I mean, I don't know if you could just have 2 things named lithium and pretend that they're, I don't know, not the same. Pretty sure it is. I'm pretty sure it's the same lithium that Nirvana was apparently big on naming stuff after.
It'd be great if they were naming this stuff and like, all right, we're gonna call this lithium. No, 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 no. Can't be 2 things. 1 thing each. What are they gonna
Yeah, we already.
what are gonna be more things than words? And apparently there are. That's why that guy got
No,
fired. He didn't have the foresight to run the naming things industry.
it'll work. Yeah. No, I believe it's the same thing though. It's the it's kind of the same as the hydrogen in the stars is the same as hydrogen on Earth. Or the
Yeah.
helium formed in the cores is the same thing you breathe in to get a high voice.
I think I only a few years ago found out that there was a thing you breathe in that gives you a low voice, like it does the opposite. I don't remember which.
I don't remember what it's called.
I don't
I've
either.
heard that.
I don't either.
Yeah.
Helium really is the dominant star of that binary star system of a good time.
Well, I mean, using logic, I don't have anything else to back this up on. But if helium is raising your voice higher because it's thinner than air or less dense than air, so it floats up, I would think that the thing that's lowering your voice would be more dense than regular air. So I guess who wants a balloon that just kind of sits on the floor? So it may be harder to come by for that type of situation. Like, I guess you need it for a specific purpose. We're having an underwater party and everyone's going to be upside down. That would work perfectly.
Why are we talking about breathing in helium? Lithium. Lithium from
yep.
from the only one thing named lithium.
Moving on, Guise. I think it's pronounced Guise or Glisa. Glise. Glise 370.
Guise. I used to do a good. I can't remember his name even anymore. Jorah Marmont. For like a week, I could do a pretty good Jorah impression, but it's. I don't know, never.
To be fair, that was about his time to shine too. It was probably about a week.
Yeah. So Guise.
So anyway, Guise.
Guise.
Yeah. Guise B is a super Earth, and it is in the Goldilocks zone. So the temperature here may be tropical, as you know, a little bit warmer but doable. It's not tidally locked, so it has day and night. It may be good for life. The atmosphere might be a little bit more dense than we're used to, but it still seems like that there is potential for life to form here. And life to form there, which means start, evolve, and stay there. I still doubt it would be a place that humans could move to and live on, though.
Yeah, and
if that matters.
One thing for the record, like all the things they're talking about, this could be like this could be like that, and I think on the Barnard Star, planets, they were saying like this would be the most viable to send something to, as it would be the closest. But even just to get to that point, there's so much shit in the way. It'd be like, all right, well, we'll just send one there. It's like it's because you need enough fuel to get it there, and I think it's like 3.5 or 3.8 light years away at their closest points. So you'd have to coordinate all that. I don't know if you had that type of a fuel that you could be able that wouldn't weigh down the entire plane. Space plane, and also would you need to like catapult around stars for gravity at that point, kind of thing? Give you like a gravity
to whip
shot.
Up speed.
Yeah.
Right. Yeah. And I mean, with the technology we have now to go that far, even the closest one that's four-ish light years, or like you said, will be less than 4 in the future if we were to aim towards that, because it would take tens of thousands of years. So it's like, would humanity even care about this project after we launch it to go there? Like, what's going to be left? And somebody gets there and, hey, we did it. My dad told me that when I got here, I should send a message back, and they'll send a message back to a nuclear wasteland, or people that don't give a shit, or who the hell knows.
It's a planet that has gone on to evolve and worship your cousin JC like a god, and all they do is fart back into the microphone and hang up on him.
That would be amazing. Yeah. Oh wait, you know what I wanted to tell you? Burn. Hang up. Another thing, though, when we talk about super Earths, so yeah, it's rocky, but the gravity is going to be, in I don't think it's exponential. It's probably proportionally greater depending on the size of the planet versus the size of the Earth. So if we're talking about a super Earth that's 3 times the size of the Earth, has triple the gravity, your muscles are going to have to be super fit to take a step. It's going to be hard just to walk at the way we're built now. It'd have to be something that evolved along with the planet that came up with the gravity that was built to, live in it.
Right. That's just how you make Supermans, right? The whole reason Superman could like jump and fly and shit was because of the gravity difference
Yeah,
on Krypton.
apparently the yellow star versus the red star, and way less gravity on Earth versus Krypton.
I was always like, so how did he come back down? Because if
That's true.
is he flying because he's used to not having gravity, or is he just jumping and being strong because he's not used to having that gravity?
Yeah, somehow, whichever direction he aims his fist, his body can just move in that direction, right? Like when he flies, it's always one fist out.
Yeah.
So flying back down does that. Also, I never understood why, if he's strong because of the sun and the gravity, why doesn't he need oxygen when he flies into the atmosphere? Like he can fly into space without a problem and just be fine.
Yeah. Yeah, I don't know what's going on in those lungs, bro.
Yeah. I fucking hate Superman. Straight up. Stupidest.
I don't remember if you shit on him on here before. I feel like you've definitely heard you shit on him, but I don't remember if it's here or not.
I think no, I definitely have.
Oh, okay.
Yeah, but I think it was less shitting on him and more like how boring he is. That it's just like, oh, surprise, they got kryptonite and Superman overcame it.
Oh yeah,
like every goddamn Superman comic.
What's gonna happen to him this time? He's gonna win.
I'll put a link because I don't think I referenced it before, but there's a couple sites out there dedicated to how much Superman is a dick, and they showcase different points in different comic books where he like beats the shit out of kids for minor stuff and like embarrasses them for no reason back in the day. Like he was 60s Superman was something.
He was just like regular acceptable 60s parenting. You could just drag a kid over in front of and hold him up by one leg and just spank him in front of the neighborhood.
And get a round of applause.
Yeah.
Well, it's about time.
Kid gets hit the whole way back home by his own parents.
All right.
So yeah, Superman sucks.
He does. He does. But moving on to the one you referenced earlier, this one's cool as shit though, Castor.
Yeah.
So to us it looks like the 23rd brightest star in the sky, about 50 light years away. But it is a single point from here with the naked eye, but it looks like there could be up to 6 stars there.
Holy shit.
Yeah, two big stars. Sorry.
Half thinking of something to say. No.
Okay. 2 big stars that seem to be accompanied by a brown dwarf. Or red dwarf, rather. Sorry, I read the wrong word there. So the red dwarfs kind of orbit the big regular stars, and they all orbit the center of mass. But then it seems like there's 2 more brown dwarfs on their own that also orbit the center of mass of all this system. Again, doesn't look like there's any exoplanets from what we can tell, but it also seems like the most likely place for there to be exoplanets would be around those 2 red dwarfs that are out on their own. And that would be also the toughest spot for us to actually track them because the luminosity of the bigger ones gets in the way of us measuring the luminosity of those 2 dwarves.
And then there's potentially a brown dwarf allegedly
That
going
is
around that
correct.
one, right?
Another guy that, brown dwarf, another way to think of it is a failed star. Didn't quite get big enough to start the fusion process, but is quite massive.
Does it harden up at that point into like any type of like a dense material, like a? I guess.
No, I think it's actually the opposite. I think it's still kind of magma-y and because it's still hot as shit.
Mm.
Like it just doesn't. Nuclear fusion didn't happen yet, but there's still a ton of friction and gravity and pressure and stuff like that
All right.
make it very hot.
And the two in the middle, the two red dwarfs that are going around each other, I think it said it takes them 22 hours for them to do a full rotation around each other or around their center of
Wow.
mass. That's fucking insane.
That's fast.
Yeah, like
Yeah.
seeing something that close that you could notice it in the sky almost, like with the naked eye, would be crazy to see something like that.
Yeah, the star's over here now. It's over there later in the day.
Yeah.
Like, yeah, because one would have to be kind of passing in front of, or you would see them change spots as they move. And I mean, the description of that skyline in general, because then on the night side, you have just these two dominant stars, just these, many, many times brighter than the moon.
Yeah.
That are not that far away, that kind of blot out a lot of the other stuff, but that's still nighttime compared to the day with the two dancing red dwarfs.
Yeah. It'd be nuts.
Yeah, it'd be cool as shit.
Like one red dwarf going one way, one red dwarf going the other way, and the brown dwarf like, what do you want from me?
All right. Where am I supposed to go?
And then just like towards the end of the video too, the whole scaling out kind of thing, because you see they spend the whole half hour talking about this handful of 65 stars, more or less. They speculate all up to like 130 million light years away or something like that.
Yeah.
So they do that, and then the end of Men in Black and like zoom out a bunch for you, and like talking about everything that's happening. It's like, holy fuck, this is all huge. And it's like, and that's what we call a galaxy. It's like, oh, there's so much stuff. Like,
yeah, and then there's billions of those,
right,
or hundreds of billions of those.
Yeah. Like, I feel like normally it's like once you get outside our solar system, they kind of like make jumps there, but they spent enough extra time in there, and it's like, oh, this is all this other shit too. It's like,
yeah. I mean, yeah, for us, those are the 65 near us. I think I don't know the number, but there's hundreds of billions of stars in our galaxy. So, I mean, how many regions of 65 stars are there just in the galaxy? We're talking probably tens of billions. It's just, mind-blowing. And that's why there has to be other planets out there capable of supporting life in some way. Maybe not us, maybe not something that's going to reach the stars. Like there's some weird ones out there even that do different things. Like even some of these, like we talked about the one around Bernard's star, it's colder than Earth, but if there was some kind of internal energy, could something live in this colder ocean? Maybe. Would that thing reach the stars? No, but could it be intelligent? Yeah.
Yeah. That falls into like the class 1, class 2, class 3 civilizations kind of thing.
Okay.
Right.
Yeah.
The 3 is capable of interstellar travel, and I think 2 is, we're not even a phase 2.
Oh, really?
Right? I think because we can't travel from. I forget. I didn't know. I didn't look this shit up.
Just like in the system, planet hopping kind of within around your own star.
Yeah, I think that might be that one.
Yeah, we could take pictures. We got big cameras that we can send there, but we can't visit yet.
Oh, one other thing from this that I forgot to Red dwarf versus Land. Oh, Iron 60. That was one of the things that they use for. They brought it up. I think it's some of the shit that's
Yeah,
like in one of the clouds, maybe, or that's.
yep. Yeah, it's a particular isotope of iron that doesn't occur naturally very frequently on Earth,
Mhm.
but it is that local interstellar cloud that we talked about. It would be more common out there. So, generally speaking, the solar wind gives us protection from that. And then our own magnetosphere and atmosphere give us another layer of protection from those hot hydrogen, whatever, in that local interstellar cloud. But there are cases where that does get through. And I think it was I don't know if it was Antarctica or the Arctic, one of the poles, that they found traces of that particular isotope, which means that even with those various layers of protection, there's still that something's going to happen. Shit gets through.
Yeah.
It didn't damage anything necessarily, but it's just
And isotope
evidence.
is what is it scale wise? What is it? So an isotope of iron. So it's not an atom of iron, right? It's big.
So isotopes are just different. I forget if they said isotope or ion, so I'll describe them
Okay.
both. But isotope is you have protons and neutrons in a nucleus.
Right.
There can be different numbers of neutrons that don't affect what the element is. So when you get
Okay.
iron 14 or iron 12, it's just referring to the number of nuclear objects there are. So 14 has 2 more neutrons than 12. Some are more stable than others. Ions are if normally an atom or a particle, an atom, whatever, has the same number of electrons as protons because they're positive and negatively charged, so it balances out. An ion either has one less electron or one more electron, and that's why you get a positively charged and negatively charged ion.
Gotcha. Right on. It's funny, we don't do, like we brought up, we don't really do chemistry episodes, but chemistry is in fucking all of it.
Yeah. Yep. Physics to kind of describe the building blocks, and then chemistry is how shit happens.
Yeah, okay. Yeah, so it's what's happening once the shit starts moving into each other and whatnot. Yep. Very fucking cool. Good shit. Yeah, these folks' videos are great. I'm a big fan of them. I'm definitely going to be watching more.
Indeed. I do have a couple more bonus exoplanet facts if you want to run through them quick.
Oh, you do?
I do. Because I noticed that this this video talked about the local bubble, but it skipped over our closest, Proxima Centauri. That is the closest star to us, and it does look like that there's an exoplanet called Proxima Centauri b. This exoplanet is located in the habitable zone of its star. It's a rocky planet that's only slightly more massive than Earth. So it seems to be like a pretty good candidate for Earth-type life or for life to evolve that we could potentially go check out, as it is the closest. I mean, we're still a ways away from having the technology, but...
And that's 6 light years away?
I think Proxima Centauri is 4.
Oh, okay.
So it's currently the closest, but Bernard star in the future will get closer.
Bernard star is going to cut you up and get inside on you and get closer.
Yeah. Proxima my ass. Let's see who's Proxima now. I also have the TRAPPIST system.
TRAPPIST?
TRAPPIST. TRAPPIST. I don't know why they named it that, but TRAPPIST 1. It's an ultra cool dwarf star. Located about 40 light years away from Earth.
Oh, I'm TRAPPIST 1.
That's why it has such a snooty name.
Ultra cool.
But this one's cool because it appears to have 7 Earth-sized exoplanets orbiting. So
Oh man.
one of them's got to be all right, right?
Yeah, isn't that the golden ratio of planets that can sustain life? 1 out of 7.
I guess, yeah, that's what we have here. 8 out of 8-ish. But they're all rocky Earth size, so I mean, just one of them's got to be close enough with the right atmosphere or some kind of atmosphere.
That'd be it. Oh, sorry, I'm yawning. That'd be good shit.
Yeah.
Make it happen,
we
Trappist.
also have, we're on our way. That one's 40 light years away from Earth, though. So
Yeah.
even, I mean, it only gets worse. Like there's another one, WASP 76b. This one is about 640 light years away. So, yeah, I mean, the light that's getting there, we might have old information at this point.
Yeah, the
But
light that just got here from there left in, what's that, man, I'm trying to do math on the fly here, 1580.
somewhere, I was going to say 16th century, we would call it. So, yeah. Hear ye. That kind of shit was still going on in the streets. And, yeah. Like the Black Plague, was it? People that thought it was devils. They didn't know about washing your hands yet.
In fact, they were not even to the point of, they just got past trying things to make sure.
Right. That's right. Facts and experiments and observation in science was the new trend. Yeah. Wait, did you just back that experiment up?
So yeah, just for perspective, that's how. Oh, that's crazy far.
Yeah, that light just got here. But this one is a hot Jupiter. Hot Jupiter, which we love on this show. So drink sponsors the show.
We do love it. I settle down to a hot Jupiter every night before bed. It calms my nerves and it steadies my hands and it sends me off to a nice night of slumber.
And it also opens my sinuses. Many things in one.
Hot Jupiter, available now at King Cullen and Genovese and CVS and Foot Locker.
Anywhere you buy your things. So this hot Jupiter is also tidally locked. And what makes it cool is that on one side, it's so hot on the day side that iron will vaporize in the atmosphere.
Holy shit.
Yeah. And then on the night side, all it says is that the temperature dropped significantly. I guess not vaporizing iron anymore is a good drop.
And not only that, like, isn't it just going to rain iron or hail iron? Because if it's all in the atmosphere, it gets cooled off. Like
I don't know if it's actually in the atmosphere. It just says that it gets hot enough that it would vaporize iron if it was in the atmosphere. But it maybe. There's another one, HD 189733B. So this one they didn't even give it a name, but it's very, very deep blue.
I heard it was that was the pager number of the guy who discovered it, I believe, right?
They just wrote that down. They couldn't remember his name, but I got his number.
I just have his beeper in my note.
It's still giving him credit.
Yeah. It was their Coke dealer. They were thanking him because this way they could stay up for 24 hours on end just doing math. You know what we're calling this guy's got. He's got. We're not gonna blow his spot up, but you know we'll. He'll know.
Then he's. I could have been nominated for a Nobel, but they didn't remember my name. But this guy is famous for its deep blue color, which is not due to oceans, but rather a hazy, turbulent atmosphere that contains tiny glass particles that scatter blue light.
Oh,
So
cool.
this shit's got glass in the atmosphere. So that rain wouldn't be fun.
No, that would not. And it
Yeah.
wouldn't do anything cool like hover above and not rain down glass on you. Like it wouldn't do cool stuff like actually I don't know, like there'd probably be some pretty neat prisms and like weird like cool looking light potentially as it gets through.
Yeah, light refraction. Yeah. It seems like it scatters light as is. That's why it gives it the color that it does from afar. So yeah. Pretty cool.
It's like you're trying to be a shitty real estate agent. Now it does rain glass down from the sky, but you could spend a lot of time indoors looking at it through the window. I'm just saying.
Have it whichever way you prefer.
Yeah, whack it.
Okay.
Whack it back.
Yeah, killing that. Kill that one down. So I got 3 more.
All right, yeah.
Kepler 452b. The nickname for that is Earth 2.0 or Earth's cousin. It's a super Earth, but it's not too much bigger. But it seems to be in the habitable zone, seems to be a similar chemical makeup, all that kind of good stuff. So it's, I guess, the closest thing that we've found so far to our planet. Again, super Earth, so it's a little bit bigger, a little bit more gravity. And the really bad side is that it's about 1,400 light years away.
Oh, man.
So probably not going to get there anytime soon.
1,400 light years.
Yeah. Which means it might not even be there anymore.
Yeah.
Like we're looking at, yeah. Yeah.
Holy crow. There's, like, they just had Charlemagne on Earth.
What year did the Mongols, what year was the Mongolian Empire?
Oh, man. I don't know when it started. I can only remember in Bill and Ted them saying, what year did the Mongols rule China? Like when they were cramming in the Circle K parking lot.
Right.
I feel like it's a little later than that. I feel like it was at least like the 12s and stuff like that.
Okay.
But yeah. Anyway, it was a while ago.
Yeah, it was a very, very long time ago that light left before it got here. There's another one that's closer, K2-18b. This one's about 110 light years away. Again, super Earth in the size of, in the habitable zone of its star. The cool thing about this one is we've actually detected water vapor in the atmosphere. It is the first exoplanet where we've made that discovery. So that's a big deal because as far as we know, life doesn't get as complex as it does or even start in the first place from what we could tell without water.
So, and that's spectrometer as well. They can do that. They can detect the water vapor in the man.
Correct.
So here's the thing I was wondering, watching this with all the really cool animation and stuff, is computer animation to a point where you can just like program physics and like basically program everything you could program about all the stuff that you're studying so that it literally is transforming that information that gets to the satellite into what it would actually look like.
Into like a visual aid. Yeah.
Is it like...
Yeah, pretty much. I mean, with some stuff where they talk about like orbits or like high level things, it's plotting points on a graph and using formulas and all math that then gets output like that, and to show a pattern. For the other, like where it's a picture from the Earth, from the surface of an exoplanet that's reimagined by somebody, that comes from the information from a spectrometer, and then just kind of like for a super Earth, if you're looking at something that's 5 times the mass of the Earth, chances are that gravity is so strong that it's going to be pretty flat. So like they use ideas like that to put that composite picture together. And then also, the chemical atmosphere. The atmosphere is mostly made up of this chemical, which typically scatters this light. So it's going to have this tinge, just like, we're nitrogen. That's why the sky is blue. So they kind of put those pieces together that way. Last one I have, I don't know how to pronounce this, 55 Concrete or Concrete E. So E, that means it's one of the, I don't know if that's a multiple star system or what, but that's the fifth thing in that system. It's a super Earth. It orbits very close to its host star, so like the surface is probably scorching, probably not livable. But if it was closer, this would be the planet that the billionaires all went to, or at least tried to mine. The high temperature and pressure on the planet. Well, I should say the planet seems to be composed of a high percentage of carbon. So the high pressure and temperature on the planet make it seem like there is probably or possibly a sublayer of diamond crystals planet-wide. So this thing has a diamond crust. Oh, you went mute.
There we go. All right.
Yeah.
That is wild.
Yeah.
Like, so would it be like, because when we were talking about 3D printed, like, carbon atoms arranged as diamond hard, would these theoretically look like actual diamond crystals?
Yeah.
Oh, wow.
Yeah, these in theory would be beautiful and crystalline and like the diamonds that we send children into mines for on this planet. There'd be a whole crust of it.
Yeah, just you think of how many. Well, they'd have to send a lot of children to that planet to get a whole planet's worth of it, right? Because they're not going to update. They're not going to update the farming techniques.
Right? Yeah, I'm going to use perfectly good adults. Get these children in this spaceship and send them out with a sandwich each.
Look how rich we are from using children. We're going to change this now. I mean, we got a good thing going right now, man.
Zales trying to tow the entire planet back this way to populate it with children miners.
A bit redundant.
Miners.
That's badass. Also, diamond crust sounds like something they serve at restaurants in Dubai on pizza. Like, here's this $80,000 slice of pizza. Has a diamond crust.
That's something that DJ Khalid eats. He definitely got that diamond crust.
Hey, DJ Khalid, it looks like you've been having another one too many times, all right? That was Rodney calling him overweight, not me. Yeah, he's rich. I'm punching up, and he's definitely taller than me.
Right, yeah. Okay.
Is that all our stuff?
That's Exoplanets.
All right.
I do know, I will also say that as technology improves, direct imaging is starting to become a thing. We're figuring out techniques to block out the light from the host star and get direct images of the planets itself. So that's still a work in progress, but that's the next cool thing in this area.
Right. Well, I might forget, so I'm just going to ask you now. So back to the moon landing being faked and stuff being fake from space. What is the argument about? Oh, where is the light from all the other stars?
Right.
That is a big thing that shows up. Where are those?
They are not in the picture due to the way cameras work, where you have to actually focus on things, and there's also filters to allow for different brightness levels and stuff like that. It's basically washed out in the pictures, and some of them. There are some pictures where they're not focused on Earth, and you can see stars in the pictures from the moon. It's just that the people that present that argument cherry pick the pictures where the intent was to take a picture of Earth and hide the stars in the background with the filter.
Gotcha. These same motherfuckers, like, photoshopping people out of the background of their own personal pictures that they're posting on stuff. It's like, yo, we weren't trying to get the stars, man. We're trying to look
Yeah.
at the Earth.
Right. It was on purpose that they kind of, all right, the luminosity, we're going to filter out anything below this luminosity because the Earth at that distance would be much brighter than anything else in the sky. But, you know, with the different exposures, it's photography stuff because the people that are standing on the moon would be able to look around and then see stars just fine.
Yeah, so why don't you stop it already, you silly geese?
It's the stupidest argument. Especially because the people that did it are still alive. And I love when they cherry pick again. There's like Buzz Aldrin was on a talk show, and they were, you know, there's the one thing where they say, I forget who was the host, but he said, when I was a kid, I was watching and I saw the moon landing. And Buzz Aldrin said, no, you didn't. No, you didn't. You saw an animation. You didn't see the moon landing. And they cut the video there and they say, here you go. Buzz Aldrin just said we never landed on the moon.
Okay. Yeah.
And then if you continue to watch that, he'll say there were no cameras on the moon, so they aired an animation. But then when we walked out of the moon, we made sure to take pictures of that, and we did all this. I played golf on the moon. I did this on the moon. I did that. So the only thing that he said was not real was the animation of the lunar module landing on the moon. Because as they were saying, landing gear down, or, you know, whatever the fuck that they were saying at the time, the TV stations had nothing to do, so they put an animation there for the people at home listening.
And he should have just left it. Like, it's the same thing when somebody tries to correct you, like, actually it's not Frankenstein, it's Frankenstein's monster. It's just like, all right, just let everybody be dumb. It's just easier sometimes to just let everybody be dumb.
Right. You're also telling a man who walked on, like, there's one guy who, like, I don't want to hear about what's easy. You don't know what the fuck training I went through to, you know, that kind of.
I like that he punched.
He didn't luck into being an astronaut.
Was he the guy that punched somebody in the face at an appearance?
He was. Yeah, the guy basically assaulted him in the street. He was like, well, not assaulted him, but harassed him in the street before he was going into a hotel and kept saying, why do you tell people this? Is it true that this? And then called him a liar. And yeah, Buzz had enough and punched him.
That's fantastic.
Hey. Hell yeah. But the motherfuckers, he went to the moon. Show some fucking respect.
Under the Guise of Science at Gmail, Facebook, and Instagram. Guise always spelled Guise.
Under the Guise of Science on YouTube. Under the Guise of Science on TikTok. At Science Guys on Twitter. And as always, thank you to Fart Barf for our opening.
Absolutely. Thank you for Homeless in Heathrow, as well as all of your other fine songs, Fart Barf. To the next time when we will be talking about